Hello everyone, welcome to Science Wisdom. I am Dr. Shilpa Bothra and the topic for today's class is matter in our surrounding. In this class, we are going to study in detail about different states of matter and effect of temperature and pressure on them. So let's begin with the chapter. So there are 5 different states of matter, that is solid, liquid, gas, plasma, and Bose-Einstein condensate. In this chapter, we are going to study solid, liquid, and gas in detail. So let's study about solids. What are solids? Solids have definite shape, distinct boundaries, and fixed volume. As you can see or imagine a brick, a chair, or a duster. The space between the particles is minimum. Therefore, the movement of the particles is minimum. The force of attraction between the particles in solid is maximum. Solid may break under force, but it is difficult to change their shape, so they are rigid. Solid tend to maintain their shape when subjected to outside force. The rate of diffusion is least as the particles are not free to move, that is, there is space between them is very less. They have negligible compressibility. Next, let's study some of the properties of liquids. Just imagine water. Water do not have a fixed or definite shape, but it does have a definite volume. Liquids take the shape of the container in which they are poured. The space between the particles is intermediate between the solid and the gas. So the movement is higher than solids but lesser than gases. The force of attraction between the particles is also intermediate. They are less compressible. That is, they are more compressible in comparison to solids but less compressible than gases. The rate of diffusion is higher than solids. So let's study about gases. The air that we breathe does not have a fixed shape or any fixed volume. Gases occupy the space of the container. The spaces between the particles in case of gases is maximum. That is why the movement of the particles is maximum. The force of attraction between the particles is minimum because they are very far from each other. They are very compressible. The rate of diffusion is more than solids and liquids. So now let's study how these states change from one state to another. The change of state is a physical phenomena and the process is reversible. That is, one form can convert back to another form that we regularly see. Just take an example of ice. Ice turns into water and then turns to steam, and we can, use this in any form. One form gets converted to any other. So it's a physical process, and the process is not irreversible. The change of solid to liquid requires energy. We have to give some heat energy, and this process is called as melting. The process of conversion of liquid to gaseous state require higher energy, increased energy, and the conversion of liquid to to gas is called as evaporation. The conversion of gas back to liquid releases out energy, and this process of change from gas to liquid is called as condensation. The change of liquid to gas again releases out energy, and this process of change from liquid to solid state is called as freezing, that is liquid to ice, right? So now let's study these processes in detail. So let's start with the first process, that is melting. What is melting? So melting is change of solid to liquid state by providing some heat energy. Now why this happens? This happens because when we heat a solid or when we provide some heat energy to a solid, the particles in the solid start to vibrate with a higher speed and they begin to move freely. Then a particular temperature arrives where this solid melts into liquid. This process of melting is called as fusion. And the temperature at which the solid melts is called as its melting point. The melting point of ice is 0 degrees Celsius, that is 273 Kelvin. So now what is this heat energy that we are giving? So this is nothing but the amount of heat energy which is required to change 1 kg or 1 kilogram of solid into liquid state at atmospheric pressure. At its melting point is called as latent heat of fusion. Next, let's study the process of boiling. What is boiling? We know, we say milk boil, water is boiling. What is that? So it is a process of conversion of liquid to gaseous state by providing some heat energy. So why this happens? This happens because when a liquid is heated, the particles, they begin to move more faster, because there is some spaces they are free, they move, but when we provide heat energy, they try to move much faster. Then at a particular temperature, this liquid begins to boil and change into vapor state, that is change into gaseous state, that is water changing to steam. Now, this boiling, it is a bulk phenomena. It cannot happen just with 1 ml of water. You cannot observe. Okay, so it's a bulk phenomena. When a liquid boils, the bulk of the liquid changes into water. For example, the evaporation of water from the sea. Okay, so the temperature at which this liquid start boiling is called as boiling point, and generally we know the boiling point of water is 100 degrees Celsius. And the heat energy that is given in is latent heat of vaporization. What is that? It is the amount of heat energy that is given to change 1 kg of liquid into gas at atmospheric pressure at its boiling point is called as latent heat of vaporization. Now, there are few substances which convert directly from solid to gaseous state without undergoing intermediate change, that is into liquid state. For example, you must have seen camphor. What happens is, when you keep camphor, that is kapoor, outside, you will observe that it directly evaporates, right? There is no liquid form of it. Now, why does that happen? So such substances which goes from change from solid to gaseous state without undergoing through liquid state, this transition, it is called as sublimation. Here is an activity which shows the same about, the ammonium chloride, when it is heated, it directly converts to vapor, and how converts to vapor. And when we cool them, it converts directly back to solid. Next, we are going to study the effect of pressure on these states. So now what happens is, when the pressure is applied on the gaseous particles, the particles come closer and they changes back to liquid state. Okay, so you must have seen the LPG cylinders, right? The gases are compressed inside a cylinder. So why? Because they get, by applying pressure, we can liquefy a gas. Okay, so we can liquefy gases by applying pressure and reducing the temperature. For example, you must have heard about solid dry ice. The dry ice. Now, what is this dry ice? It is solid carbon dioxide. It directly gets converted to gaseous state on decrease of pressure of 1 atm, that is 1 atmosphere, without coming into liquid state. This is the reason that we call solid carbon dioxide as dry ice. Next, we are going to study the process of evaporation. Okay, so let's take an example. When we leave the water uncovered for a longer period of time, the level of water decreases. Now, why this happens? It's because some of the water has evaporated. Now, we dry our wet clothes in the sun. Why? For the moisture to evaporate. What we say, let the water evaporate. It means let the clothes dry up. Okay. So now what happens is the particles of matter, they are continuously in random motion. Okay. So when we give any temperature in any gas, liquid or solid, the particles they have different amount of kinetic energy. For example, in case of liquids, a small amount of particles are at the surface. So these particles at the surface, they have kinetic energy and they are able to break the forces of attraction of other particles and get converted to vapor. Okay, so this change of liquid into vapor state, okay, at any temperature which is below the boiling point is called as evaporation. So so when we dry up our clothes, the water does not boil. The water present inside the cloth does not boil. It evaporates below its boiling point. Okay. Okay, so there is a change of state from liquid to gas. So unlike boiling, which was a bulk phenomena, evaporation is just a surface phenomena. That is, the particles changes from liquid to vapor state from the surface. So particles from the surface, they have enough energy to overcome the forces of attraction and they get converted to vapor state. Next, there are few factors that are affecting this process of evaporation. The rate of evaporation depends on the surface area, temperature, humidity and wind speed. I would say just think your clothes are drying outside. So when your clothes are drying outside, what you see, that you spread those clothes on a rope. Why do you do that? In order to increase the surface area, right? So because the surface area is increased, what happens is the rate of evaporation increases. Second, now it's easier to dry up clothes on a rainy day than on a sunny day. Okay. I'm sorry. It's easier to dry clothes on sunny day than on rainy day. Why? Because there is an increased temperature on a sunny day. So rate of evaporation increases when we increase the temperature. Third, increase in humidity decreases the rate of evaporation. So if there is a humidity in the atmosphere, your clothes will dry late. I mean, it will take longer time than in the less humid region. Increase in the wind speed increases the rate of evaporation. That is very obvious. That is, if it is windy, my clothes will dry up sooner. So these are few factors that immensely affect the rate of evaporation. You must have observed that after coming from jogging, your body feels colder, right? Or cooler. This is one of the cause and an example which shows that evaporation causes cooling. So when a liquid evaporates, the particle of the liquid absorbs heat from the surrounding and they evaporate and makes the surrounding cooler. Few of the example, let's see. People sprinkle water on the roof or open ground in hot areas because during evaporation, water absorbs heat, makes the hot surface cooler. Second, during summer, we sweat more because during evaporation, the sweat absorbs the heat from the body and makes our body cooler. Wearing cotton clothes in summer keeps us cool because cotton absorbs sweat and then when we sweat, the sweat evaporates and the body feels cooler. Okay, so in this class we have studied about the different properties of solid, liquid and gases and how one state changes to the another state. So next time we'll meet with a new topic. Till then, thank you. Bye-bye.